Okay, today then we're going to be looking at properties of exponents. When we look at this example, you all know that 5 to the third power means 5 times 5 times 5. And we know that 5 to the 12th power would mean 5 times 5 times 5 times 5 times 5 times 5 times 5. How many more do I have to go? Times 5 times 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and one more. Correct? And if I'm multiplying all those together, I can rewrite that as 5 to what power? There are 12 here, 12, 15th. Now, in your calculator, oftentimes, when you're working with powers, you get such big powers that they can't write it down. Okay, so then they will use this exponential form, 5 to the 15th power. So we're going to be looking at some of these shortcuts. Now, the only way that this actually works, the shortcut, is when we look at our base numbers being the same. Okay, if I had 3 to the third power times 5 to the 12th power, we would not be able to use the same shortcuts. So our goal today is to work on the properties of exponents. So to start with, we're going to look at what is the power. The power or exponent is the little number, and that tells you how many times you're multiplying the base number. And the base number in this case is 2. This is read 2 to the 6th power, or you can read it 2 to the power of 6. Now, depending on your calculator, you may see a symbol to help you use exponents as either a caret symbol or a y to the x power symbol. Okay, the first property we're going to look at is the product of powers property. In other words, if I have a power raised, or number raised to the power times the same base number raised to a power, I could take a shortcut and add the exponents or the powers, just like the example that we had earlier. Here's another one, 3 to the second power times 3 to the 7th power, since the base numbers are the same and I'm multiplying. And in your brain, you might even think this. I'm thinking 3 times 3, and over here I'm thinking 3 times 3 times 3 times 3, 7 times. So together, how many 3's would I have? 9. So that's how you take 2 plus 7 to get 3 to the 9th power. Make sure you write down the examples that go with it. They'll be good references for you. Okay, now the second property for exponents is the power of a power. Now here's where I have a quantity raised to a power. So if I have some number to the power and then that whole quantity is raised to a power, then you multiply the exponents or powers. Here's an example. I have 5 to the second power, that quantity raised to the fourth power. In other words, you're saying whatever 5 to the second power is, what is 5 to the second power? 25. I'm going to take that to the fourth power. Or it's the same thing as 5 to the 8th power, multiplying 2 times 4 to get 5 to the 8th power. And the last one is to find the power of a product. Now you notice these two numbers are different. Okay, I have A times B raised to the same power. I can actually do the opposite of distributing. I can break it down and say that A to the m power times B to the m power. So here's an example. If I have 2 times 3 all raised to the 6th power, that's the same as taking 2 to the 6th power times 3 to the 6th power. It's like using the distributive property. Okay, so in a nutshell, then to summarize what we've done so far, we've looked at the first 3. Then anytime I have a base number, the same base number raised to a power times another one base number, the same, raised to a power, you add the exponents or powers. If I have a power raised to a power, you multiply them. If I have a quantity, I can distribute that. And now, here's your new one. If I have the same base number being divided by the base number raised to a power, I subtract my powers. Here's an example. 5 to the third over 5 to the first equals 5 to the 3 minus 1, which would be 5 to the second power. Now, how does it work? Well, if you think about it, 5 to the third means 5 times 5 times 5, divided by a 5. You know how we've done the canceling out? And I'm left with 5 times 5, or 5 to the second power. So this is kind of like you're thinking of how come that works. All right, now this next one is the one that kind of gives you the little more challenge. Suppose I have a negative power. What does that mean? I like to tell students it has nothing to do really with negative numbers at all. When we were working with scientific notation, you would have 10 to a negative power if you had a small decimal number. So what you're looking at is just smaller numbers or fractions. It always goes under 1. So if I have a number raised to a negative power, I put it under 1. For instance, if I have 5 to the negative third power, that means that I have 1 over 5 to the third power. And if I were evaluating what that is, that would be equal to 1 over 125. And we'd leave it written that way. Okay, now suppose I start with 1 over some base number raised to a negative power. What happens is it's not going downstairs now, it's going back upstairs is the way I like to think of it. Now here's the thinking behind it, because I have 1 over a to the nth power. But what happens when you divide by a fraction? You actually multiply by its reciprocal, a to the nth over 1, which would be equal to a to the nth power. So let's give us an example with this one. Let's go back to our 1 over 5 to the negative third power. That is going to be equal to, now that we know our shortcut, 5 to the third power. Because down here it would be 1 over 5 to the third. And when I take 1 divided by 1 over 5 to the third, flip it, and you get 5 to the third. So probably the one that's going to be maybe a little confusing to start with is this property number 6. I always say if I have a negative power in the denominator, it can never stay there. It has to go upstairs. Let's say we have 1 divided by 2 to the negative fourth power. Well, 2 to the negative fourth power is 1 over 2 to the fourth power. So when I take 1 divided by 1 over 2 to the fourth power, that's the same as 1 times 2 to the fourth over 1, which is 2 to the fourth power. So all you're doing is bringing it back upstairs. Okay, now there's one property that always gives us some trouble, and that is any number to the 0 property. Any number to the 0 property. Okay, so let's stop for a second, and we're going to do a paper folding demonstration. So any number to the 0 power from our paper folding demonstration is equal to 1. Any number. 1,258,000 is going to be, to the 0 power would be 1. 2 to the first power is 2. I only have 1 2, it's a 2. 2 to the second power means 2 times 2, or 4. 2 to the third power is 2 times 2 times 2, or 8, and so forth. Okay, now the term monomial. Monomial means has one term. These are all examples of monomials. So please write that term down. Later on, we're going to talk about polynomials and binomials. And due to that prefix, we're going to find out what that means. But mon means one, has one term. Now, earlier this year, we talked about terms. Terms are units that are separated by addition or subtraction. Okay, I can have a bunch of things be multiplied together, but that still represents one term. So it would be considered a monomial. Because no addition or subtraction separates these, this is still considered a monomial. We're just going to be simplifying this monomial. So we're going to put together what we can. Let's try it. The quantity 3xy to the fourth power times 2xy. Now, if I got rid of my parentheses, there's nothing being raised to the powers here. It's just basically saying 3 times x times y to the fourth times 2 times x times y. Anything I can just multiply together, like whole numbers? Right, the 3 and the 2. Now, they're not being raised to a power. The 3 is not being raised to the fourth power, so I'm just looking at 3. 3 times 2 is 6. Okay, what about my x's? This is an x to the what power if there's nothing there? To the first, and this is an x to the first, so now I have x to the second. What do you do when you multiply powers are the same? Look at your properties. Add the powers. Okay, and then this is a y to the fourth, and this is y to the first, and I get y to the fifth. Now, is there anything that I can combine or simplify here? No. You have simplified that monomial. Okay, let's try this next one. Now, I do notice that there is a quantity that's being raised by a power, so we need to do that first. It's kind of like following your order of operations. The 3 is being taken to the second power, the x is being taken to the second power, and so is the y. What is 3 to the second power? 9. 3 times 3 is 9. X to the second power? X squared, or to the power of 2, and y to the second power. Now I could take all of that times 2xy. Okay, I'm not finished yet. What can I still do? I'm not even adding, I'm just multiplying. So do I need the parentheses anymore? No, and you can just visualize, I just remove all those parentheses. 9 times 2 I can do, and I get 18. I can take an x squared times an x to get x to the third. Remember, you use the addition property of powers or exponents. And what about the y's? Y to the third. Now remember, this only works if you're doing what? Multiplying the same base numbers, okay, with the powers. And then here's our last example. I have x times x to the second power, and you get x to the third power. Okay, let's try these examples. If I have 73 to the 0 power, what does that equal to? 1. We're simplifying and it's 1. If I have 1/2 to the negative first power, what's that mean? When you have a negative power, what's it mean it goes under? 1 over 1/2 to the first power. What is 1 over 1/2? Never have a fraction down here. Never have a fraction on the denominator. Equals, no, it's 2. Because you're thinking 1 divided by 1/2, or the same as 1 times 2 over 1, which is 2. That's going back to your rules of fractions. And this last one, 13 to the negative x power, means that I'm going to have 1 over 13 to the x power. Now, can I simplify that anymore? No. Is there a fraction at the bottom? Is there a negative exponent at the bottom? No. So that's the way we leave it. Okay, this one, are my base numbers the same? So I can apply the property of adding your exponents. What's a negative 1 times or plus 1? So I have 8 to the 0, which is 1. Now, in most cases, you're leaving it as 8 to some power, unless they're asking you to solve. Okay, what about this one? Okay, so what's this one? This would be 4 to the, well, think in your brain, 6 plus negative 4 gives you 2. So I have 6 to the second power, which is 36. Now, you just may leave it right there, because you got 6 plus a negative 4. So you just add your powers. What's 6 plus a negative 4? My mistake there. It's not 6 to the second power. It's 4 to the sixth power. 4 to the second power, which is 16. Thank you for catching that. You take 4 to the 6th power times 4 to the negative 4th, you add your powers, and you get 6 plus negative 4 is 2, but it's 4 to the 2nd power. Glad somebody's awake today. And the last one, I have a power raised to a power, multiply them. So what's a negative 2 times 2? So I have 5 to the negative 4th, but I do not want to leave it as a negative power, so it'll be 1 over 5 to the 4th.